Hello there, sleepy wanderer. I'm glad you found your way here to this quiet little corner of the cosmos. Whether you're wrapped in blankets, listening to the hum of your own breath, or simply lying still as the world hushes down around you, this moment is yours. Out beyond the windows and rooftops, past the clouds and the cold wind, above the blinking satellites and soft dust of moonlight, something ancient stirs, something vast, invisible, and quietly brilliant. Tonight, we drift toward it. Tonight, we wonder, can two black holes, those silent shadows of gravity, ever find each other in the great dark and fall into one? It's a question that's both simple and impossibly deep, like water in a well so dark you can't tell where the reflection ends and the depth begins. But before we leap into those gravitational abysses, let's begin closer to home, here on the soft bed of Earth, where gravity keeps your body gently pressed against the mattress, where time moves like a river, mostly unnoticed until you look up and realize another year has passed. There's something comforting about gravity, isn't there? Something predictable and anchoring. You drop your pen and it falls. You breathe out and the air knows where to go. Gravity has always been our quiet companion, holding us close, keeping everything from drifting apart. But sometimes, somewhere out in the great deep of space, gravity does something stranger. It folds, it collapses, it curves so tightly that light itself can no longer climb free. That's how a black hole begins. Not as a monster, not as a villain, but as a story of too much mass in too small a space. Picture a star, a great burning one, older than any memory, having spent its life fusing hydrogen into helium, turning pressure into heat, holding itself up with the power of light. And then, like all things in time, the fuel runs low. The star's brightness flickers, not to your eye, but inside, in the secret furnace of its core. And when the push of light can no longer balance the pull of gravity, the star surrenders. It collapses. It falls inward, not like a falling apple, but like a folding page of reality. The outer layers peel off, the inner heart tightens, until the pressure becomes so great that even space itself can't hold firm. And then it vanishes, not into nothing, but into a place where place loses its meaning. A black hole is not a thing in the ordinary sense. It's a where that is nowhere. It's a knot in the fabric of space-time, a region where all paths, all light, all futures curve toward a single point. We call that point the singularity, but don't worry. Names are just tiny rafts we cling to in the ocean of what we don't understand. You won't fall in tonight. We'll just float nearby, listening. Black holes don't shine. They don't talk, but they speak in their own way, with gravity. A gravity so deep that it stretches time. Clocks near black holes run slower, like syrup compared to water, like dreams compared to morning. If you could stand near one, your heartbeats would echo into eternity. You watch the stars above spin faster, the universe age while you remained unchanged. Of course, you'd never really stand near one, not safely, but isn't it beautiful to imagine? Now imagine this. One black hole, silent and alone, drifting through the galaxy, and far, far away another, maybe born from another collapsed star, maybe formed in the heart of a quiet cluster, surrounded by the ghosts of ancient suns. They are both dark, yes, both voiceless. But gravity is a patient matchmaker. Over millions, perhaps billions of years, the two black holes begin to move toward each other, not with haste, not like cars or meteors, but slowly, spiraling, gently responding to each other's presence, like dancers who don't know they've begun to waltz. And here's the part that feels like magic. As they orbit, they create ripples, not in air, not in water, but in space-time itself. Imagine throwing a pebble into a pond, and instead of ripples on the surface, the ripples go deeper into the pond's memory, into the very rules that say what distance and time mean. These ripples are called gravitational waves. They stretch and squeeze the space they pass through so subtly that it takes instruments the size of buildings to notice them. And yet, they are real. In 2015, for the first time, we heard them, not with ears, but with machines designed to listen to space-time's softest sighs. It was like hearing the universe breathe for the first time. That first whisper came from two black holes merging, two invisible giants, caught in a spiral, drawing closer with every orbit. The dance becomes faster, more urgent, more radiant in its silence. And then, not a bang, not an explosion, but a fusion. A singularity welcoming another. One black hole, now bigger, rounder, darker. The universe adjusted, and the waves of that meeting traveled outward, like a drumbeat through the fabric of all things. But we're getting ahead of ourselves. Tonight, we're still in the beginning. Still in the part where we feel the quiet hum beneath the stars. Still in the wonder of what it means to be drawn to something you can't see. Black holes, in their own strange way, are the universe's greatest listeners. They listen to gravity, they listen to light, though they never let it leave. And maybe, just maybe, they listen to each other in that deep, invisible language of curved space and curved time. It's easy to think of space as cold, as empty, but when you understand that even nothingness can ripple, can stretch and sing, then even silence becomes something to cherish. Every black hole is a place where the story of a star ends and another story begins. They are not graves, they are not erasers, they are transitions, portals in physics, metaphors in thought. And when two of them meet, it's not destruction, it's not collision, it's unity, a slow, inevitable embrace. Here on Earth, we barely notice the sky changing. Light reaches us from stars that may already be gone. Galaxies drift, but too slowly for our eyes. Yet somewhere, far beyond where telescopes can see, black holes are circling. And when they merge, the universe trembles, not violently, but reverently, as if something sacred has happened, and space-time itself pauses to record it. Perhaps that's why we wonder about them. Not just because they're mysterious, but because they mirror something in us. The longing to understand what we cannot see, the pull towards something more, the quiet knowledge that even in darkness, even in silence, there can be connection, there can be union, and so we drift, you and I, on the edge of knowing, wrapped in starlight and the gentle pressure of thought. Black holes may never speak, but tonight they've told us a little something about gravity, about time, about what it means to come close, to spiral in, to merge, not with fanfare, but with quiet inevitability, like sleep arriving, like dreams blooming just behind your eyes, like one soft darkness meeting another until there's no edge between them anymore. There's a peculiar comfort in knowing that stars, for all their radiant defiance, are temporary, that somewhere out there, in the velvet hush of the cosmos, even the most brilliant light must one day flicker and fall inward. It's not a tragedy. It's not even an ending, not really. It's more like a transformation, a final exhale, a moment of surrender to something deeper, a return, perhaps, to the gravity that once kindled them. Tonight, let's gently follow one of those stars, not the moment it dies, but everything that comes after. Imagine a star many times heavier than our sun, a true giant. Its heart is a churning forge, a place where hydrogen is pressed into helium, where heat and pressure live in delicate balance. For millions of years, the star shines by holding that tension, the push of radiation keeping gravity's pull at bay. It's a glorious tug of war. But every fuel runs out, and when it does, there's no longer anything left to resist gravity's quiet insistence. The core begins to collapse, not like a crumbling wall or a falling tree, but inward, 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 until even the atoms that once resisted pressure begin to fail. Electrons are crushed into protons, protons into neutrons. Eventually, even those may collapse, and what's left is something not even light can escape. The star vanishes from view, leaving behind only its gravity, a kind of invisible fingerprint in the fabric of space. And so a black hole is born. It doesn't blink or shine or spin in silence. It's not the kind of darkness you get when the lights go out. It's a deeper absence, a place where time and space trade places, where the path forward curves inward, always inward. From the outside, we see the event horizon, the edge of no return. Cross it, and the rest of the universe becomes unreachable. It's not a wall. It's not a surface. It's a boundary written by gravity itself, like a gentle do not disturb sign hanging on the door of the cosmos. But the story doesn't end with one black hole alone in the night, because the universe, in its endless sprawl, is generous. Stars are everywhere, and so are their endings. Over eons, black holes emerge like punctuation marks at the ends of stellar lives, some small, some massive, some utterly titanic. Most travel alone, drifting like deep-sea creatures through the interstellar dark. But some are born close together, twins in collapse, or come to orbit through the slow choreography of gravity over billions of years. Picture two of them now, each with its own invisible border, each with a singularity buried at its center. They are orbiting one another, caught in a spiral shaped not by light or color, but by gravity alone. There's no glow to their motion, no flare, no song audible to ears. But if you could see the curves they create in space, you'd see a beautiful pattern, like ripples in honey or whirlpools in ink. Their dance is long and slow at first, each circle pulling them ever slightly closer. As they move, something extraordinary happens. They emit gravitational waves, soft ripples in the very geometry of reality, not metaphorically, literally. Space itself stretches and squeezes as those waves pass through. The black holes are losing energy to these waves, but not in a way you might notice. They aren't dimming. They aren't slowing. They're drawing closer, orbit by orbit, like two raindrops swirling down a drain. Gravity is whispering, and the universe is listening. For a long time, these whispers were lost to us. We didn't know how to hear them. But deep in quiet laboratories on Earth, we built instruments, long tunnels with mirrors, light bouncing between them, tuned not to sound or image but to vibration in space-time itself. When we finally heard the song of merging black holes for the first time, it wasn't a roar or a blast. It was a chirp, a quick upward slide in frequency, like the universe clearing its throat, and in that chirp was the memory of two black holes spinning faster and faster, merging in a moment of perfect silence. That moment, invisible as it is among the most powerful events in the known universe. The mass of the black holes isn't simply added together. Some of it is converted into gravitational energy, a burst of ripples flying outward at the speed of light. If you could capture just a tiny fraction of that power, you could light up entire galaxies. But the waves don't burn or glow. They move through you, through planets and stars, unnoticed unless you're listening in exactly the right way. And what remains after the merger? Not a debris field, not an explosion, just a single, larger black hole, quieter than before. It rings briefly like a struck bell, then settles into stillness. Its horizon is smoother now. The chaos of two curving paths has become one. From afar, it's impossible to tell that this object was once two. No scar, no seam, just gravity distilled. Somewhere in all of this is a kind of quiet miracle. These black holes, devoid of light, of structure, of sound, still manage to reveal themselves through the curvature of space, and their story, from star to collapse, to orbit to union, is told not with color or heat, but with the bending of the very reality we live in. It makes you wonder, doesn't it? What else moves silently beneath the surface of what we think is still? How many collisions, how many hidden dances are taking place beyond our senses, in places we'll never visit, in times we'll never see? The universe is vast, yes, but it's also full of movement, full of quiet inevitabilities. And perhaps that's what makes black holes so mesmerizing. Not their danger, not their darkness, but the way they anchor a kind of stillness in motion. They don't rage, they don't shine, they simply are. They move not because they choose to, but because gravity shapes the path. And when they meet, it is not a clash. It is a merging, a returning, a folding inward. To lie here, now, and think of them is to stretch your imagination towards something intimate and immense. It's like holding a pebble and imagining a mountain, like listening to silence and hearing a story inside it. The black holes are out there, but the wonder is in here, in your breath, in your heartbeat, in your softness against the bed. And as the two continue their slow spiral in the dark, drawing closer orbit by orbit, the waves of their union ripple outward. Not just in space-time, but in us, in our questions, in our sense of awe, in that quiet place where mystery lives, not to be solved, but to be felt. And the spiral narrows, and the silence deepens, and gravity, in its gentle certainty, brings what once was apart slowly back together. You might think that silence is nothing, that stillness is the absence of story. But the more we look into the sky, the more we learn that silence often holds the most profound conversations. A single beam of starlight takes thousands of years to reach us, and when it arrives, it whispers a tale not of sound, but of time and distance. And yet, there are places in the universe where not even that light escapes. Only gravity, only memory, only a hush so deep it curves the very meaning of movement. Tonight, we turn our ear toward the fabric beneath everything, space-time, a word so delicate it sounds like a sigh, and yet it holds all that exists. Every star, every breath, every black hole drawing its slow orbit in the dark. Space-time isn't something we float inside. It's not a container. It is the stage and the music and the thread that runs through it all. And like any thread, it can bend, it can stretch. And when pulled by something heavy enough, like two black holes locked in orbit, it can ripple. Picture space not as emptiness, but as a gentle surface like a pond before dawn, smooth, cold, reflective. Drop something heavy in, and you see rings spread outward. But the rings of space time aren't made of water or light. They're made of reality itself, stretching and compressing as waves pass through. Gravitational waves, they're called, born not from motion alone, but from the kind of motion that twists and strains the deepest structure of existence. When two black holes spiral toward each other, they do not create light. They do not glow or shine. They orbit quietly, patiently, and as they spiral inward, their immense masses drag the space around them into tighter and tighter circles, like dancers winding into a spin so fast and so close you can't tell where one ends and the other begins. They lose energy, but not in the way you might expect. There's no friction in space, no air to slow them down. What they lose is given to space-time itself, poured into it like sound into a bell. This is what creates the ripple, not because the black holes intend it, but because their very motion is too intense, too heavy, too fast for space to ignore. Imagine space-time trying to stay smooth while two mountains whirl within it. The only option is to ripple outward, sending out a silent alarm that says, something massive is happening here. And for billions of years, those ripples traveled. Through gas and void, through dust and time, they moved, always at the speed of light, always with the same quiet rhythm. They passed stars that never noticed, crossed galaxies full of sleeping planets, flowed through clouds of hydrogen, and past wandering comets. And then eventually, they reached a small blue world tucked into the arm of a spiral galaxy, where a few curious beings had built delicate machines to listen. These machines, long arms of light and mirror, so precise they could detect a change smaller than the width of a proton, were waiting. They didn't know when a wave might come, or from where, but they were ready, tuned to the faintest tremble of spacetime's skin. And one day, in September of 2015, the wave arrived. Just a flicker, a shiver in the mirrors, a chirp in the data. It lasted only a fraction of a second, but in that moment, something magnificent had been confirmed. We had heard the sound of two black holes merging. It wasn't a sound in air, of course. It was a translation, a ripple in space-time becoming a tone, a frequency, something we could measure, and in doing so, something we could feel. The wave had traveled for over 1 billion years. It began when the first animals were learning to swim in Earth's ancient seas. It journeyed through time as forests rose and fell, as continents drifted, as humans began to dream. And all that time, the wave was coming, carrying with it the memory of two black holes who had finally become one. There is something tender about that. The idea that the universe holds on to moments like that space-time, vast and indifferent as it may seem, ripples when a union is made, that two invisible bodies finding each other in the dark could cause the cosmos to hum. And yet, the wave that reached us was so small, so delicate, a trillionth of a meter in amplitude, smaller than small, fainter than faint. And still, we heard it. That's what wonder is made of. Not just the event, but the listening. Not just the silence, but the way we lean into it. What does it mean then when we say that space ripples, that time stretches? These aren't metaphors. These are the rules of our reality. Einstein first suggested it, that gravity isn't a force pulling on objects, but rather the result of mass bending space and time. That what we feel as gravity is simply the natural path objects take through curved geometry. You're not pulled down by Earth. You're moving along the curves Earth makes in space-time. You fall because space is sloped, like a ball rolling on a warped sheet. And black holes? They are the steepest curves of all. Their presence is like a dimple so deep that once something rolls in, it never rolls out again, not even light. Their curvature is so intense that time itself bends inward. A clock falling into a black hole appears, to an outside observer, to slow down. It never quite reaches the event horizon. It just ticks slower and slower until it seems frozen in place. But from the clock's perspective, it falls normally. Nothing strange happens at the edge. Time continues. Reality continues. But for the rest of the universe, the moment is stretched out, painted long across space-time like a thread pulled tight. This is the beauty of relativity. That time is not a single drumbeat heard by all, but a local rhythm, changing depending on where you stand and how fast you move. Near a black hole, time becomes syrup. Away from it, time flows like water. And when black holes dance together, their syrupy clocks twist and tangle until, in the final spin before the merger, time itself seems to fold. You might wonder, if time and space are not fixed, then what is? What remains true when the geometry itself is soft and shifting? The answer is gravity. Gravity is the artist and the rule. It draws the shapes, writes the paths, decides the rhythm. It is not a force acting on things. It is the shape that things move through. It is the whisper that tells light which way to bend, tells planets where to orbit, tells black holes how to fall into one another. So as we lie here, breathing softly, held down by Earth's gravity, gentle compared to a black hole's, but still constant, we are part of that same geometry. Our bodies curve space-time too, just a little. Our hearts tick with the same clocks that slow near singularities. We are made of the same matter that once made stars, that once fell inwards, that once sent ripples across the galaxy. And perhaps the most astonishing thing is this. In a universe where nothing stays still, where even space itself can flutter, there is meaning to be found in the curves, not in the brightness, not in the noise, but in the deep, quiet structure beneath it all. The fabric that allows things to spiral and merge and ripple without ever raising a sound. The stage on which two black holes can circle for eons and then vanish into one, leaving behind only the faintest shiver and a new shape where once there were two, and it goes on. The ripples travel, the clocks turn, the space curves, and somewhere, far away, another black hole waits. When you think of motion, you might picture footsteps on a floor, the sweeping of birds across a sky, or the slow turn of Earth under the weight of clouds. But there is a kind of movement, far more quiet than footsteps, deeper than wings, older even than the oceans pulling away from the shore. It is the spiral, the graceful, inevitable drawing together of two bodies bound not by strings or stories, but by space-time itself. Tonight, we drift toward that spiral, toward two black holes circling closer in the great stillness of the cosmos. There's a strange tenderness in imagining two black holes in orbit, not just spinning, but circling each other endlessly, as though the universe itself has paused to watch. They have no eyes, no hands to hold, no voices to call with, only gravity. And yet, that's enough. That quiet pull is everything. When two black holes orbit one another, it isn't chaos, it's choreography, a duet unfolding not in sound, but in curves. Each orbit sends a tremor through space-time. Each pass brings them infinitesimally nearer. And though the space between them may once have been vast, millions of kilometers across, their fate was written the moment they were caught in each other's pull. For as they dance, they lose energy, not in heat, not in light, but in those ripples we now know how to hear, gravitational waves. Each turn sends more of those waves outward, stealing away a sliver of their orbital strength. You might expect this to slow them down, but gravity has other plans. As the orbit shrinks, they spin faster. Just as ice skaters pull their arms in and twirl quicker, black holes draw closer and race along their spiraling track. Imagine watching them from far away. At first, it's like watching two shadows gently circling. No color, no glow, just the barest distortion of the stars behind them. But as they near one another, the speed increases. The spirals tighten. Time compresses. Each orbit takes less time than the last. The frequency of their waves climbs like a rising note, a chirp too deep to hear, but too real to ignore. Faster now, tighter, closer. This moment, known to physicists as the inspiral, is not sudden. It can last millions of years. And yet, in its final moments, the last seconds, everything accelerates. Two vast objects, once so separate, rush toward each other at nearly half the speed of light. Their horizons stretch, deform, bend under the intensity of their motion. They are no longer neat spheres. They are tidal bodies, distorted by each other's gravity, folding toward union. And then, in one final orbit, they touch. Their event horizons meet. Not a crash, not a shatter, but a seamless swallowing. The space between them ceases to exist. There is no longer a this one and a that one. Only one singular curve, one horizon, one mass, larger and smoother than before. In that instant, a burst of gravitational energy is released, not like a flash, but like the ringing of a perfect bell. We call this the merger. But in truth, it's a kind of settling, like two notes resolving into harmony. The newborn black hole, formed from the dance, is not perfectly still. It wobbles, it vibrates, it sings in waves. This final act is called the ring down, and it is, in a sense, the black hole's lullaby to itself. The echoes of its formation ripple outward in every direction, traveling through galaxies, through nebulae, through everything, unnoticed by nearly everything, until perhaps they reach a listening world. It is a strange kind of love story, isn't it? Two things that do not touch, do not speak, do not shine, and yet find each other across the stars, pulled by nothing more than mass in the geometry of space. And still, they come together, not in destruction, but in completeness, in unity. A black hole, once doubled, now whole. And what of the time between, the long ages before the final spiral? There is something to be said for slow inevitability, for the quiet patience of gravity. These black holes may orbit for billions of years. Their paths may take them through dense clouds of gas, through regions lit by starlight, past clusters of stars too far to care, and all the while, their gravity stirs the surroundings. If gas is nearby, it may spiral inward, heated by friction, glowing just before it vanishes forever. In such cases, the black holes may leave a brief trace, a flash, a flicker, a moment of brightness to mark the dark. But most often, their story is hidden. No fire, no farewell, just waves, just gravity doing what it has always done, bending, drawing in, making paths that curve toward each other. If you could watch from 1,000 light years away, the black holes would seem still. If you could wait long enough, you'd see motion. And if you could listen in the right way, not with ears, but with mirrors and lasers, tuned to the fabric of space-time itself, you'd hear the crescendo, that final chirp as the merger completes. In a way, that chirp is a cosmic punctuation mark. It says, here in this moment, something changed. Two centers of darkness became one, and the universe, vast as it is, noticed. And you, here, resting beneath a ceiling or a sky, you noticed too, not with machines or numbers, but with wonder, with the quiet recognition that even the darkest things are not alone, that gravity, invisible and constant, connects, that space-time, for all its softness, is strong enough to carry a memory across the universe. So much of physics is about motion, about how things move and how they don't. We track velocities and spins, orbits and falls. But the motion of black holes is special. It's not just a path through space, it's a path through reality itself. Two black holes spiraling together are not just moving, they are remaking the map, stretching time, twisting space, drawing new lines in the fabric that holds us all. And we, delicate creatures on a fragile world, have learned to read those lines, to hear the chirps, to say, there it is, the echo of a merger from 1 billion years ago. And in that hearing, we understand something vast and intimate, that the universe is not a place of cold silence, but a place where even the most invisible motions leave traces, where even the darkest bodies can merge, where even the quietest spirals shape the stars around them. So let the black holes spin, let their orbit continue, until the moment comes when motion becomes one. And when that happens, when the ripples spread again across space and time, we'll be listening, quietly, carefully, tenderly, as gravity does what it does best, bring things home. If you close your eyes and listen long enough, the world begins to quiet beneath you. The rustle of thought slows, the breath eases, the weight of blankets becomes a kind of gravity, holding you gently against the mattress of earth. And in that stillness, you can begin to feel the shape of something larger, not a noise, but a presence, a background hum stitched into everything. It's the hush of the universe, thinking, remembering, rippling softly from the deepest places where time forgets how to tick. Tonight, we'll follow one such ripple, the afterglow of union, the gentle ring of two black holes becoming one. The moment of merger is not an explosion. It's not a scream. It's more like the quiet sigh of space-time settling into a new shape. The two black holes have spiraled, have touched, have blurred their edges, and melted their horizons into a single event. The instant this happens, something extraordinary is born. Not only a larger black hole, but a wave, a whisper, an echo that begins to ripple outward from the scene. This is not the kind of wave that lifts water or carries air. It is a ripple in reality itself, a stretch, a squeeze, a passing pulse in the geometry of everything. This final vibration, called the ringdown, is like the last note of a bell rung in the vacuum of space. It fades, but it does not vanish. It travels tirelessly across billions of years and billions of kilometers as unbothered by time as moonlight on still water. It carries no light, no sound, no scent, just information, just memory, the shape of the merger, the mass of the result, the tempo of the spiral, all encoded in the trembling of the cosmos. And yet, for all its power, the wave is shy. By the time it reaches us, it is barely detectable. It changes the length of a 4-kilometer detector arm by less than the width of a proton. A breath, a blink, an echo of an echo. And still, we caught it. Still, we listened. And in that listening, we heard one of the most spectacular events the universe allows, the fusion of two invisible giants. The black hole that remains after the merger is different, not only more massive, but more round, more still, more complete. For a moment, it quivers, like a bubble settling after a gust of wind. The horizon smooths, the wrinkles relax. It is a return to calm, but a new calm, the kind that only follows transformation. Like silence after a song, not emptiness, resonance. If you could hover safely just outside its event horizon, you'd see nothing of the original two, no seam, no scar, just one smooth curve, enclosing a mystery so deep time itself cannot escape. You wouldn't see the merger, you'd see what it left behind. But in the ripples traveling outward, you would hear the story, written in geometry, unfolding like a lullaby for the stars. And this, perhaps, is one of the quietest truths in all of physics, that black holes can merge not with chaos, but with grace. They do not fight, they do not fracture, they fall inward, always inward, until even their identities dissolve into the shape of something larger. The new black hole doesn't remember them separately, it simply is, more massive, more stable, spinning now with the shared momentum of two. A fusion not just of matter, but of motion. We call this spin the final spin, and it holds clues. How fast the new black hole turns, how it curves the space around it, depends on how the originals danced. If they spiraled like mirrors, their spins cancel. If they twirled like gears, the result spins faster. Every ring down is a signature, a fingerprint pressed into space-time that lets us reconstruct the cosmic ballet that came before. And what comes next? That's the beauty, nothing flashy. The black hole settles in. It exists. It holds its secrets. The universe moves on. But it is different now. The map of space-time has changed, ever so slightly. A new shape exists where once there were two. A new wrinkle, a new well, a new silent anchor tugging on passing stars and errant gas clouds. The quiet influence begins again. Over time, this new black hole may drift, or it may sit in place, a monument of memory surrounded by galaxies and the slow chatter of starlight. If it's part of a larger system, it may find new companions. It may someday merge again, each merger adding to the mass, each ripple adding to the story. And all the while, we are listening. From our tiny perch on a spinning rock, orbiting an average star, we've learned to feel these cosmic tremors. Our detectors, LIGO, Virgo, and others, do not see the black holes directly. They do not image the merger, but they hear space-time ripple. They read the rhythm. They decipher the song. It's a little like hearing music played behind a curtain. You can't see the instruments, but you can know the players. You can know their size, their tempo, the moment the melody turned into harmony. It changes something knowing this, that we are not only surrounded by stars, but by waves we can't feel. That space is not a stage, but a participant, moving and trembling in response to gravity's most dramatic choreography. that even when all light is gone, there is still something to be sensed, still a shape, still a story. And when we detect that story, we can run it backward. Like a detective in the dark, we trace the wave to its source. How massive were the black holes? How far away? How long ago? Often, we discover they merged when Earth was still young, when plants were just beginning to whisper in green, when the continents had not yet learned their modern names. The wave traveled while mountains rose and wore down, while species came and went, while minds began to wonder. And now, as you lie here, mind quiet, body still, wrapped in the soft gravity of your bed, that same wave passes through you, through your pillow, through the walls, through the trees outside. You don't feel it, but it's there. A fingerprint of two black holes, long gone, still echoing across space. It reminds us that nothing is ever truly still, that the universe is a sea of invisible motion, that even silence has structure. The final ring of the merger is not a goodbye, it's a signal, a promise, a new curve added to the infinite sculpture of time. And just like that, the wave continues. Outwards, always outward, past us, past the next stars, past the edge of what we know. It carries no memory of where it's been, only a message. Something beautiful happened here, something enormous, something quiet, something true. Somewhere beyond thought, beyond the clutter of headlines and kitchen lights and half-remembered errands, lies a kind of calm that doesn't ask anything of you. It doesn't need answers. It doesn't even need you to stay awake. It's the hush behind the stars, the stillness between gravitational waves. And when two black holes merge and the last ripples quiet into the void, what remains is not noise, not spectacle, but a kind of poised silence, the calm after the cosmos has exhaled. This silence isn't empty. It's full of aftermath. After the merger, after the ringdown, what remains is a new black hole, bigger, heavier, quieter than before. It doesn't shine, of course. It doesn't announce its presence with a flare or a glow. It simply is. And yet, in its very being, it carries the signature of everything that came before, of the total mass, the angular momentum, the still warmth of gravity, curled so tightly that even light cannot wriggle free. The newborn black hole doesn't wobble forever. Its final tremors fade, and it begins to settle into its most stable state. If it were alone in the universe, it could sit like that indefinitely, a region of space-time so perfectly curved that no one inside or outside can change it. It is what physicists call a Kerr black hole if it spins, or a Schwarzschild black hole if it doesn't. Either way, it's smooth, featureless, unchanging. But let's not mistake unchanging for lifeless. Even in perfect silence, it's holding something profound, a singularity at the center, a place where our mathematics fail, where all distances collapse into one, where the laws of physics reach their edge and peer over uncertain. No one knows exactly what happens there. It could be a point, a twist, a gateway, or perhaps just a question written so deeply into the universe that even time cannot unfold it. And yet, despite this unknowable center, everything outside the event horizon is predictable. A black hole's exterior is determined by just a few numbers: its mass, its spin, and if it has one, its electric charge. These three values define everything the universe needs to know about this new object. No trace remains of what the original black holes looked like, whether they were spinning or still, whether they formed from stars or from gas clouds. Whether they once circled with the elegance of dancers or crashed like drunks in the dark, all of that is lost or perhaps hidden behind the veil of the event horizon. This concept is called the no-hair theorem. It's a poetic way of saying that black holes are bald. They have no messy details, no distinguishing features, no scars, just a smooth, absolute boundary and the few numbers that describe their identity. It's as if the universe believes that once something is pulled deep enough into gravity's well, the past becomes irrelevant. All that matters is what remains. There's something hauntingly philosophical about that. The idea that when things collapse together, not in destruction, but in transformation, they become simpler, not more complex. That as the universe folds inward, it sheds its clutter. That the black hole, in its starkness, is not just an object, but a kind of reduction, a refinement, the purest expression of gravity's pull. And yet black holes aren't completely sealed, not entirely. At their edges, strange things may be happening. Stephen Hawking proposed that black holes aren't perfectly black after all, that they emit a faint glow, a trickle of radiation born from the quantum jitter of particles at the horizon's edge. It's not much. It's not enough to light up the sky. But over unimaginable timescales, trillions of years, this Hawking radiation might slowly shrink the black hole, a whisper of evaporation, a vanishing so slow it seems eternal. But that's a different story, a tale for the far future. For now, our newly merged black hole rests, a dark sphere in the cosmic tapestry. And perhaps it will remain that way forever, unless gravity finds it a new partner. Because the story doesn't always end at one merger, black holes can gather in clusters, in galaxies, in the hearts of stars that never formed. They can wander toward one another again over eons, in slow spirals that begin the whole process anew. The black hole that exists now might someday find another, and the dance begins again. Imagine this: a galaxy spinning with stars like fireflies, with dust and gas weaving its lanes. And in its center, a supermassive black hole, millions of times heavier than the sun. And near it, another, born from a smaller galaxy that was swallowed long ago. The two drift toward each other, shepherded by gravity, by time, by the sheer curve of space. And once again, the spiral tightens. Once again, the ripples begin. Once again, the universe hums. And somewhere else, perhaps in the thin darkness between galaxies, two smaller black holes, the remnants of ancient stars, drift closer. No one sees them, no one hears. But the fabric of space-time shifts ever so slightly. A distant ripple begins its journey, and we are here, listening. There's something wondrous about this, the idea that we, fragile beings made of stardust and carbon and memory, can reach across the universe with nothing but curiosity, that we've built instruments capable of catching the faintest tremor, that we've learned to translate those ripples into stories, into music, into understanding. Every merger we detect is not just an event, it's a window, a signal from a past that predates us, a whisper from regions we will never visit. These mergers aren't rare, they're happening all the time. Somewhere in the sky, at this very moment, another spiral is tightening. Another black hole is ringing. Another wave is on its way. The universe is full of this quiet violence, these silent symphonies of mass and motion. And yet rather than fear it, we can marvel. We can know that even the darkest places are not empty. that even collapse can lead to unity, that even the end of light can make the beginning of a story, because black holes are not just voids, they are chapters, they are consequences, they are the curves written by the weight of time itself. And when they merge, they leave behind not silence, but form, not destruction, but structure, a new shape in the map of the cosmos. And so, somewhere, the new black hole turns, quiet, still, complete. The last ripples have faded, the wave has passed, the universe has stretched, adjusted, remembered, and far, far away, a world turns beneath soft clouds. And on that world, someone lies awake, wondering what it means to be drawn together, not by light, not by voice, but by gravity alone. Time is a funny thing when you really start to feel it, not as numbers ticking on a clock or the length of a day, but as something more fluid, more intimate, a kind of texture to existence, a rhythm you can't quite hum, but that's always there beneath your skin, moving in slow waves through the bones of the world. And nowhere does time behave more strangely, more poetically, than near a black hole. It's easy to imagine time as a constant. It feels steady from the warmth of your bed, from the gentle unfolding of dusk into night. But time, in truth, is pliable. It stretches, it slows, it sags under weight. And nowhere is it stretched more deeply than at the edge of a black hole. There, time becomes syrup, thick, slow, reluctant to pass. The stronger the gravity, the slower the ticking. And inside a black hole, time doesn't just slow, it seems to fall inward like water down a drain, always forward, always deeper, never back. Einstein saw this first in his equations. That gravity wasn't a force in the usual sense, but a curvature of time and space, that a massive object didn't just pull, it bent the stage on which everything moves. And black holes? They are the steepest bends, not a hill, but a well with no bottom. Stand near one, and your clock would tick slower than someone's far away. Stand closer still, and you'd feel seconds begin to drip like honey, stretched into minutes, into hours. And if you crossed the edge, that soft, invisible boundary called the event horizon, you would fall through time itself. But here's the twist. From your perspective, nothing unusual would happen. You wouldn't feel time changing. You'd fall normally, smoothly, maybe quickly, depending on the black hole's mass, but always in accordance with gravity's unflinching rules. The weirdness, the miracle, happens to the observers watching from afar. To them, you'd seem to slow. You'd appear to hover just outside the horizon, your last image lingering, frozen, as if caught in an endless goodbye. They would never see you cross. You would vanish into redshift, fading from sight, a ghost made of gravity. Time doesn't stop at the horizon, not for the one falling in. It's just that inside time and space switch rolls. Every path leads to the center, not just in space, but in time. The singularity becomes your future, as inevitable as tomorrow. Once inside, you cannot resist. All lines curve inward. It's not just a place you're going, it's a moment you cannot avoid. This bending of time isn't limited to black holes. It happens here on Earth too, faintly. Your head ages slightly faster than your feet because it's farther from Earth's center. Astronauts aboard the International Space Station, speeding above the planet, experience time differently than you do lying still. It's all real. It's all measurable. We are creatures afloat in a universe where time flows unevenly. It's like water down a rocky hill, sometimes fast, sometimes slow, but always flowing. And when two black holes merge, the flow of time dances. The extreme gravity at the edge of each horizon tugs on space-time so tightly that the timing of their final orbits, their chirping death spiral, becomes a kind of cosmic clock. By measuring that clock, we can know their masses, their spins, their history. In the tightening frequency of those waves, we can hear time being pulled, squeezed, twisted. And yet, all of this happens in silence. There's no ticking, no chiming, just the steady curve of reality. It's easy to forget that everything, light, gravity, even thought, moves through time. But time is not a road we walk on. It's part of what we are. Our heartbeat is a clock. Our memory is time made solid. Our lives unfold not just in space, but through this strange, invisible medium that can bend around stars and fall into black holes. What then is the meaning of time to a black hole? If nothing escapes it, does it remember anything at all? If light cannot leave, does the past even exist beyond the horizon? Some physicists believe that the information, all the patterns of matter and energy that fall into a black hole, may not be lost entirely, that it could be encoded somehow in the surface of the horizon itself, like a cosmic hologram. Others argue that black holes slowly evaporate, and with them their contents. That time, like mass, is eventually released as radiation. But we don't know. We can't know. Not yet. Black holes guard their secrets behind that boundary, offering only gravity and riddles. But what we do know is that time and gravity are deeply entwined. You can't touch one without the other trembling. That's why black holes, though they appear silent, are deeply connected to motion, to causality, to the flow of reality itself. They aren't just places in space, they are destinations in time. And perhaps that's why they feel so dreamlike. Because dreams, too, are slippery with time. In sleep, minutes can stretch, hours can vanish. You can fall and fly and return before the alarm. In dreams, we slip through the seams of reality, bending memory, bending meaning. Not unlike a particle tracing a path through curved space-time, moving not toward a destination, but toward inevitability. So as you drift now under the weight of blankets and breath, know that you too are wrapped in time, that each second is a soft ripple moving outward from the moment you were born, curving gently through every choice, every wonder, every wish you haven't yet whispered. You are not separate from time. You are part of it, as fluid as light, as folded as space-time itself. And black holes, those quiet maestros of time's symphony, are not merely cosmic vacuums. They are clocks, not for us to read, but for the universe to measure itself by. They mark the end of one rhythm and the beginning of another. And when two of them merge, it is not just mass and energy that coalesce. It is time itself, stitched into a new shape. So sleep softly now, with the thought that the universe is always folding, that time is always bending, and that somewhere, beyond sight and sound, two black holes have curved not just space, but time into something new. What does it mean for something to disappear, to cross a threshold and never return? We are taught to fear disappearance, to associate it with loss, with absence, with silence that can't be answered. But in the world of black holes, disappearance is not erasure, it's transformation. The mystery isn't just that nothing escapes a black hole, but that everything which falls in seems to vanish without a trace. No smoke, no scar, no echo, just gravity made deeper. And tonight, under the hush of nightfall and the quiet hum of stars, we drift into one of the strangest questions the universe has ever asked. Does information vanish inside a black hole? To understand this puzzle, we need to remember what information means in physics. It's not just thoughts or facts. Information is the exact configuration of every particle, its position, its energy, its direction, its spin. In theory, if you knew the complete information of every atom in a snowflake, you could rewind time and see how it formed, what clouds it drifted through, even the breath that set it spinning. Information is the fingerprint of the universe. It tells the story of what was. Now imagine taking something filled with information, a book, a tree, a star, and letting it fall into a black hole. From the outside, you see it stretch, redshift, and fade until all that remains is the black hole, a little more massive than before. But where did the information go? Is it stored? Is it smeared across the horizon? Or is it gone, truly and completely? Stephen Hawking startled the physics world when he suggested that black holes slowly evaporate through what's now called Hawking radiation. Tiny pairs of quantum particles flickering into existence at the edge of the event horizon sometimes see one escape while the other falls in. Over time, this process saps the black hole's mass. The black hole shrinks, and eventually, if the theory holds, it vanishes entirely. But this raises a problem. If the black hole disappears, and with it the information about everything it swallowed, then the universe has lost something fundamental. And in physics, that's a big deal. The rules say information must be preserved. Even if something is destroyed, the details of how it was destroyed, the blueprint, the history, must remain somewhere. So where does the information go? For decades, no one knew. Some argued that it's truly lost, that black holes are the universe's great forgetters. Others said it must be hidden in the Hawking radiation, scrambled so thoroughly we can't yet see it. Still others believe the event horizon acts like a memory surface, encoding everything that falls in like a projection cast onto its edge. And so the information paradox was born, a soft war between the certainty of quantum mechanics and the serene mystery of general relativity. Two great theories of reality whispering different stories at the edge of a black hole. It's a paradox that hums beneath modern physics, unresolved, delicate, quietly profound. Some think the answer lies in holography, the idea that everything inside a volume of space could be described by information on its surface, like a three-dimensional world projected from a two-dimensional skin. In this view, the contents of a black hole are not lost, but translated, etched into the outer fabric, like a cosmic diary written in invisible ink. Others believe wormholes may play a role, secret tunnels linking the inside of black holes to other places in the universe, or other universes entirely. But none of this has been proven. It is all theory, elegant, tantalizing, and incomplete. The black hole remains a locked room, a puzzle box, a place where gravity and quantum mechanics speak different dialects of the same language. And still, we wonder, what does it mean to remember something that no longer exists? What does it mean for the universe to forget? Perhaps the answer lies not in resolving the paradox, but in embracing what it teaches us. that knowledge is fragile, that boundaries are not always clear, and that even the deepest truths can be curved by gravity. And yet, we keep searching. We build new theories. We test strange ideas. We look for clues in the patterns of Hawking radiation, in the tremble of merging black holes, in the very texture of space-time itself. Because even if black holes seem like endings, they are also beginnings, questions that pull us inward, challenges that stretch our understanding, reminders that the universe is far more clever than we imagine. And maybe, in some strange way, the information isn't lost. Maybe it's transformed, like a whisper carried through a canyon, changed by echoes, reshaped by stone, but never entirely gone. Maybe black holes don't erase, they rewrite. Maybe everything that falls in is still there, in some folded way, written in curvature and spin, waiting for a theory we have not yet dreamed. So when two black holes merge, and their horizons ripple into one, what happens to the information inside them? Is it combined? Is it canceled? Is it recorded in the shape of the ringdown, in the frequency of the final wave? Or is it tucked behind the veil, safe in the singularity, invisible but intact? We do not know. And yet the question alone is luminous. It means we care. It means we look at the night sky, not just with awe, but with inquiry. It means that even in the deepest darkness, we believe there is something worth understanding, something worth remembering. And maybe that's what black holes offer us, not just mystery, but meaning, not just silence, but the suggestion of something more, a hidden pattern, a veiled memory, a curve so deep that it folds answers into questions, and questions into the quiet music of the stars. So rest now. Let your thoughts fall gently inward. Let the gravity of wonder draw you close. Somewhere in the folds of space-time, two black holes have become one, and everything they were, every photon, every atom, every thought that shaped them, may still be there deep inside, folded and waiting, like a secret held in the palm of the universe. Not all black holes are created equal. Just as raindrops can be tiny or heavy, and trees can grow as saplings or ancient giants, black holes span a vast range of sizes, from the remains of single stars to titans that anchor entire galaxies. And though each one is defined by its quiet pull, by its refusal to release even a sliver of light, they are as varied as the dreams that wander through the night. The smallest black holes we know of are born in the death throes of massive stars. When a star many times the size of our sun exhausts its fuel, its core collapses under its own weight, and the force of gravity crushes it into something smaller than a city, an object with so much density not even light can escape its surface. These stellar mass black holes, usually between a few and a few dozen times the mass of our sun, are scattered throughout galaxies, wandering like lonely shadows in the starlight. Sometimes we find them by their companions. If a black hole orbits with a star, it may draw material from it, heating that gas as it spirals inward. The gas glows, bright and hot, announcing the presence of an otherwise invisible partner. In these cases, the black hole becomes known not by its darkness, but by the hunger that surrounds it, a radiant silence wrapped in fire. Then there are the middle weights, the ones we call intermediate mass black holes, harder to find, rarer to confirm. These may weigh hundreds or thousands of times more than the sun, yet they often drift alone, quiet and unlit, somewhere between the scale of a dying star in the grand architecture of a galaxy's heart. Some may form when smaller black holes merge. Others might be born in dense star clusters, where gravity folds many stars into a single, unseen core. Like half solved riddles, these black holes sit between the known and the vast, whispering of gaps in our understanding. And finally, there are the giants, the supermassive black holes, millions, sometimes billions, of times more massive than our sun. We do not fully understand how these cosmic monarchs are born, whether they grew slowly, swallowing stars and dust over eons, or formed rapidly from the collapse of massive clouds in the early universe. But we see their fingerprints everywhere. At the center of nearly every large galaxy, including our own Milky Way, lurks a supermassive black hole shaping the motion of stars, curving spacetime like a slow tidal breath at the heart of creation. Ours is called Sagittarius A star. It sits dark and serene at the galactic center, surrounded by stars whipping around it at speeds that betray its hidden mass. We cannot see the black hole itself, but we know it's there, a presence defined not by what it gives off, but by how it shapes what's near. Recently, we even managed to glimpse its shadow using a globe-spanning network of telescopes stitched together into one great eye. What we saw was not the whole, but the absence, a soft ring of light, curved by gravity, wrapped around nothing. And that nothing, that silent void, connects us to everything. It's possible, even likely, that the supermassive black hole at the center of our galaxy has merged with others in the past. As galaxies collide, so do their central black holes, slowly spiraling toward each other in dances that take hundreds of millions of years. Though separated now by vast distances, those twin behemoths may one day come close enough for gravity to take over, beginning that slow spiral toward unity, toward waves that will echo across the cosmos. When that happens, and it surely will, the gravitational waves will be too deep, too slow for our current detectors to catch. They'll hum not in seconds, but in years. We will need new instruments, quieter ears, giant telescopes in space, pulsar networks tuned to the vibrations of time itself. And when we build those tools, we may begin to hear the deep songs of galactic hearts falling together, not just the quick chirps of stellar black holes merging, but the long chords of titans combining. There's something humbling about this hierarchy, from black holes the size of cities to ones that dwarf entire solar systems. They're all made of the same stuff, gravity and mystery, and yet they play different roles. The small ones are like drifting embers, the intermediate ones, smoldering puzzles, the supermassive ones, anchors, steadying the swirl of stars, regulating the rhythm of galaxies. And all of them can merge. It doesn't matter how massive they are or what path they took to become what they are. If two black holes come close enough, they will fall into each other. It may take eons. It may require the friction of surrounding gas or the gravitational nudges of other stars. But the result is always the same. The spiral begins. The ripples spread. The horizons blur. A new black hole is born, heavier, darker, more complete. And so the universe builds, from collapse to union, from light to silence, from many to one, over and over, in patterns we are only just beginning to trace. We listen for those mergers. We map their masses. We calculate their spins. Each detection is like a sentence from a larger book, one we are reading with wide eyes and open hearts. Because when we hear those waves, those faint quivers of space-time, we are not just learning about black holes. We are learning about how structure forms, how galaxies evolve, how gravity sculpts not just matter, but meaning. The mergers of black holes are not accidents. They are architecture. They are the scaffolding upon which cosmic history hangs. And through it all, gravity remains the quiet artist, drawing lines across the sky, curving the paths of stars and dust, guiding black holes into orbits that will end always in togetherness. So lie still for a moment, feel the weight of your own body, the soft press of Earth beneath you. That too is gravity. That too is a tether. You are not separate from this great spiral. You are part of it, a thought suspended in motion, a moment within time, wrapped in the same forces that merge stars and bend light. And somewhere, beyond the galaxies we can see, another black hole is circling a twin, quietly, patiently, a slow orbit beneath the music of the stars, waiting, as gravity always waits, for the moment when many become one. There's a quiet beauty in how things grow together, not suddenly, not in sparks and shouts, but slowly, silently, the way roots find each other beneath the forest floor, or rivers carve new valleys without asking for applause. In the universe, but some of the most astonishing partnerships are the ones that take shape without a sound. And at the center of galaxies, where stars orbit like fireflies in a vast lantern, black holes and galaxies seem to grow not as separate stories, but as one long breath, exhaling together, expanding in concert, twin rhythms written into the dark. Tonight, we drift gently toward that bond, toward the strange and tender link between the hearts of galaxies and the giants that lie hidden at their cores. Supermassive black holes, those immense beings millions or billions of times the mass of our sun, don't float through space without anchor. They nestle inside galaxies, like seeds in fruit, deep and quiet, unseen but central. It turns out that the mass of a supermassive black hole is often linked to the galaxy it lives in, not just vaguely, but precisely, almost like a dialogue. The heavier the black hole, the more massive the bulge of stars surrounding it. It's as though the two grew together, shaped each other, as if every swirling galaxy spun a heart at its core, and that heart, in turn, whispered instructions for how the stars should gather. No one knows exactly how this connection formed. It could be that black holes shape their galaxies from the start, feeding on gas, regulating the formation of stars with powerful winds and jets, a kind of gravitational sculptor, carving out the galaxy's rhythm. Or it could be the other way around, with the galaxy nourishing the black hole, feeding it starlight and matter until it swells into a supermassive being. Maybe it's both. Maybe the relationship is more like a dance, a back and forth between mass and gravity, between collapse and expansion, between silence and formation. What we do know is that when galaxies merge, as they so often do, their black holes are brought along for the ride. Picture two great swirls of stars approaching over millions of years, each carrying a hidden weight at its center. As the galaxies intertwine, their stars are flung into new orbits. Gas clouds collide, triggering waves of starbirth. And somewhere in that mess, the two central black holes begin to feel each other's pull. They fall into an orbit, they spiral, and slowly, so slowly, they inch closer. At first, they may be separated by thousands of light years, But gravity is patient. Stars near them may act like gravitational messengers, carrying momentum away. Gas may swirl and fall, adding drag. And over time, the black holes drift inward until they are only light years apart. Then light minutes, then light seconds, and then the merger begins. A galactic duet collapsing into a single note. It's a process that takes hundreds of millions of years, but we've seen hints of it. Galaxies with two bright cores, like twin eyes peering through the dust. In some cases, radio telescopes pick up the wobbles of jets or double pulses of light, signs that two black holes may be in the final steps of their spiral. And while we haven't yet heard the gravitational waves from these giants merging, we know they must exist, humming in frequencies so low and slow we can only sense them by their effect on distant pulsars, spinning stars whose regular rhythm is like a cosmic metronome. If space-time ripples between us and them, the timing shifts ever so slightly. A galactic murmur passed through gravity alone, and so the black holes merge, and a new supermassive heart is born, one that now anchors a new, larger galaxy. The process repeats. Galaxies collide, black holes merge, a kind of cosmic gardening. And over billions of years, this dance of mergers sculpts the universe, shapes the webs of galaxies, draws threads of gravity through the void. It's remarkable to think that these dark, invisible objects, so compact, so quiet, could play such a vital role in building the luminous structure of everything. But perhaps that's the way of things, that sometimes the unseen is what shapes the seen, that gravity, though invisible, is the weaver behind the scenes, some tying stars into spirals and stitching black holes into galaxies. And through it all, the growth continues. Black holes feed on gas growing heavier. Galaxies gather stars, spinning wider. The relationship holds. The balance remains, as if the black hole and its galaxy are reflections of each other, not in shape, but in purpose. One holds the light, the other the dark. One births stars, the other ends them. And yet together, they form something whole. We often imagine black holes as lonely, but maybe they are more connected than we think. Maybe every black hole, from the stellar to the supermassive, carries within it the memory of its surroundings, the gas that fed it, the stars that danced too close, the other black holes it once embraced. And maybe the galaxies around them remember too, holding that gentle tug at their center, always spinning around an unseen guide. This unity, this entanglement of the bright and the dark, speaks to something deep, not just in physics, but in us. That opposites are not always in conflict, that darkness can anchor light, that silence can hold structure, that something as invisible as gravity can draw everything toward meaning. And so, next time you look at a picture of a galaxy, a spiral like a seashell, or a cluster like a cloud, remember that somewhere deep in its heart is a black hole, silent and massive, holding it together. And that black hole didn't appear alone. It grew with its galaxy, folded itself into its history, was there in the beginning, will remain at the end, and perhaps one night far from now, that galaxy will meet another, and the stars will swirl again, and the black holes at their hearts will spiral, and the universe will stretch and hum and reshape itself, not loudly, not with fire, but with gravity, with grace, with the slow, tender pull of togetherness. So rest now, knowing that even the most massive forces in the universe grow not in solitude, but in relationship. That black holes and galaxies are not separate stories, but chapters in the same long unfolding tale, one of silence and spin, of merging and becoming, of gravity ever weaving the stars. There is something magical about learning to listen to the quietest things. The hush between heartbeats, the stillness in a room just before sleep arrives, and in the wide, wide cosmos, where most things are too far and too faint for our ears or eyes, we've begun to listen in a different way, not with sound, but with silence's own language, with instruments that don't seek light or color or heat, but the tiny, trembling rhythm of the universe itself. Tonight, we drift closer to the tools that made this listening possible, to how we first heard the soft song of two black holes falling into one. It might seem strange that we can hear something that doesn't make sound, but gravity doesn't need air to speak. It talks through the stretching of space, through the swelling and squeezing of distances too small to notice, too vast to ignore. And when two black holes merge, they send out waves in space-time, not noise, but pattern. And if you can detect that pattern, you can read it like a score. You can hear it like a lullaby from across the universe. For decades, this idea was just that, an idea. Albert Einstein predicted gravitational waves over a century ago, but he doubted they could ever be detected. The shifts they cause are unimaginably small. A change in length, smaller than the width of a single proton, stretched across kilometers of space. It was like trying to measure the wiggle of a shadow cast by a hummingbird flapping on the far side of the moon. And yet, we tried. We built observatories, not the kind that look up, but the kind that feel. LIGO, the Laser Interferometer Gravitational Wave Observatory, stretches across fields in Washington and Louisiana. Each one is shaped like a giant L, with arms 4 kilometers long. Inside each arm, a beam of laser light bounces back and forth between mirrors, measuring the distance with exquisite precision. If a gravitational wave passes through, one arm stretches ever so slightly, while the other shrinks, and the pattern of the light shifts, just enough to whisper that the fabric of space has moved. It took decades to get it right, to learn how to cancel out every vibration, trucks on roads, waves in the earth, even the tremble of atoms in the mirrors. The stillness required was deeper than silence. It was discipline made into machinery, patience turned into physics. And then, in September of 2015, it happened. A signal, a chirp, just a blip in the data. But within that blip was a message from over 1 billion years ago. Two black holes, each dozens of times the mass of the sun, spiraling into one another and merging. The first gravitational wave ever recorded. The first time we had heard the universe move. The sound, when converted into an audible frequency, was simple, a rising whoop, like a drop of water skimming upward. But in that sound was a miracle. Not only did it confirm Einstein's century-old prediction, it proved that black holes exist, that they merge, that their collision sends waves across space-time, and those waves can reach us long after the event itself has faded. Since then, we've heard dozens more. Some black holes larger, some smaller, some fast, some slow. Each wave is like a fingerprint, unique in its curve and pitch, and we've begun to learn their language, how the frequency tells us the mass, how the wave's shape tells us the spin, how the pattern after the merger, the ring down, tells us what kind of black hole remains. We are no longer just watchers of the sky. We are listeners, and soon we'll hear even more. New observatories are coming. Virgo in Europe, Kagra in Japan, Lisa in space. These will tune in to lower frequencies, longer signals, even more distant mergers. They'll hear the deep songs of supermassive black holes, the slow groans of cosmic giants circling one another at the centers of merging galaxies. And perhaps even stranger things, because now gravitational wave astronomy doesn't just confirm what we know, it opens doors to what we don't, to the possibility of new physics, exotic objects, collisions we never expected, black holes that spin too fast, or merge too cleanly, or make waves too strong. Each new signal is a question wrapped in data, waiting to be unspooled. And the beauty is this: gravitational waves travel through everything. They pass through gas, through stars, through entire galaxies, undisturbed. Unlike light, which can be scattered or absorbed, these waves glide effortlessly across the universe, carrying the purest story of the event that made them. They are messengers no wall can stop. They are time travelers, bringing news from billions of years ago to our doorstep. And we, quiet beings on a quiet planet, have learned to listen. There's a poetry to it, to the idea that even in the vast cold darkness, events of great weight, of great beauty, can be heard, if only we are still enough, if only we listen carefully enough, and that the tools we built, with lasers and mirrors and hope, can catch the faintest quiver in the universe's bones. You're lying here now, beneath ceilings or skies, your own body held gently by Earth's gravity. That same gravity, familiar and soft, is the cousin of the waves we hear. The same force, but stretched to its most intense, its most extraordinary. The same curve that keeps your breath moving in rhythm, that holds oceans to the shore, now turned into a cosmic whisper, into the ripples of two black holes becoming one. And what do we make of this? That we can hear such distant collisions, that we can trace their shapes, their spins, their masses from the quiet of a laser beam in a building on Earth? We make stories, we make wonder, we make meaning, because science, too, is a kind of lullaby, a way of singing the universe to ourselves, of saying gently, I see you, even when the universe hides in shadow, even when it speaks in gravity instead of light. So sleep now, knowing the sky is not silent, that even the darkest events make music, that black holes, though they shine not at all, can still be heard, and that we, in our smallness, are listening, still, always, quietly brilliant, like gravity itself. There is a map unfolding above you, though you can't always see it. Not one of roads or borders, but of something deeper, a map drawn by movement, by memory, by the long, slow tremble of space-time. It stretches across galaxies, across billions of years, and yet somehow it reaches you. It reaches all of us. This map doesn't just show where things are, it shows how the universe feels, how it breathes, how it shifts in response to gravity's quiet music. Tonight, we drift into this new way of seeing, not with light, but with waves, into a cosmos that is no longer only visible, but audible in silence. We are used to looking up and navigating by stars. Since the beginning of story and wonder, we've charted the heavens with our eyes, by the light of suns and galaxies, by the shadows they cast and the colors they send across time. But black holes don't glow, and gravitational waves don't shimmer. They can't be seen by any telescope. Instead, they must be heard with instruments that read the ripples in space-time itself. This is the quiet revolution of gravitational wave astronomy, that we've added another sense to our cosmic perception. We're no longer bound to photons. We now read the universe through its motions, its warps and wobbles. We've begun slowly, gently, to map the dark. Each detection is a point on that map. Each wave that rolls through our detectors marks a place and a time, two black holes that once danced and then became one. And as more signals arrive, the map becomes richer. It gains layers, patterns, a history built not of light, but of gravity's silent fingerprints. This map shows us things we could never see before, regions of space where light can't reach us, either because it's blocked by dust or because there was never any light to begin with. Events that happened long before Earth knew breath or trees or dreams. Collisions that took place on the far side of the sky, too distant for even starlight to tell us the story. And yet we know, because the waves came, because they moved through the stars, through galaxies, through everything, untouched, unchanged, and reached us still singing of their source. This way of seeing, of listening, gives us a new kind of vision. It's like hearing the heartbeat of the universe and using each beat to trace a life far beyond what eyes alone can show. Even more powerful is what happens when we combine senses, when we see and hear the same event at once. This is called multi-messenger astronomy, and it marks a new era in our understanding of the cosmos. In 2017, for the first time, we witnessed such an event. Two neutron stars, the ultra-dense remnants of massive stars, spiraled into each other, much like black holes do. Their merger sent out gravitational waves caught by LIGO and Virgo. But this time, there was also light, a burst of gamma rays, a glow of kilonova fire visible across telescopes on Earth and in space. For the first time, we saw and heard the same cosmic collision. That moment changed everything, because now we weren't just tracing curves. We could read the light, analyze the elements it created, trace how heavy atoms like gold and platinum may be forged in such mergers. We could watch the waves and the shine converge. It was like seeing thunder and hearing lightning, like watching two hands come together from opposite sides of the sky. And as we refine our instruments, this will happen more often. We will catch more of these dual messengers, gravitational waves paired with light, with neutrinos, with X-rays, with silence. Each one a note in the expanding map, each one a line added to the song of everything. Imagine one day seeing a dot on this map, not just of what happened, but of when. A gravitational wave from a black hole merger, a light echo from its surrounding disk, a pulse from a star thrown off balance, a moment reconstructed from many messengers, each arriving in their own way, but all telling the same tale. In this way, the universe is no longer just a scene, it is a story, not just an image, but a motion. We are learning to read the past in new ways, to understand not just what is, but what became. And black holes, once thought to be the silent villains of this story, are now among its clearest narrators. They tell us where matter collapsed, where galaxies came together, where gravity ran deep. And as we map their mergers, one by one, signal by signal, we begin to see the shape of space-time itself, the quiet curves, the ancient collisions, the places where darkness bloomed into something more. There's a strange comfort in knowing that, even in the absence of light, there is still knowledge, still structure, still motion, that the universe does not stop speaking when the lights go out. It just changes languages. We are not yet fluent in this language, but we are learning. Every chirp, every ripple, every faint quake in our detectors teaches us a new word, a new phrase, a new way to describe a universe that has never stopped unfolding. And somewhere out there, far beyond what light can show, another merger has just begun. Two black holes have started their spiral, the space between them narrowing, the waves beginning to form. It will be billions of years before that signal reaches us, but it's on its way, a line already drawn on the map, a whisper already set in motion, and you, lying quietly now in your own soft orbit of thought and breath, are part of that same map. You too are shaped by gravity, by time, by the echoes of distant things. So close your eyes, if they aren't already. Feel the soft pull of the mattress beneath you, the planet beneath that, the sun beyond that, and the quiet curve of the galaxy beyond even that. You are not separate. You are within the map, traced by starlight and waves alike. And out there, between galaxies, between epochs, between the folds of spacetime itself, a ripple moves closer, not with urgency, but with purpose. The universe is still singing, and we are still listening. Some questions drift into the mind like starlight, soft, persistent, impossible to ignore. And one of them, perhaps whispered most often in quiet corners of thought, is this: if black holes are out there, waiting in the dark, could we ever make one? Not by accident, not by the death of a star, but on purpose, with intention, in a laboratory shaped not from stone or steel, but from equations, particle beams, and thought. Tonight, as the world around you hushes into the soft rhythm of sleep, let's wander into that most speculative of spaces, where theory becomes dream, and dream becomes the spark of science. To build a black hole, you need mass, not just a lot, but enough. Enough to fold space-time until there's no path left but inward. For a star to collapse into a black hole, it must reach a threshold where the pressure of light can no longer resist the hunger of gravity. The same rules would apply in any attempt to create one artificially. You'd need something so dense, so compact, that even light would be caught in the grip of its curve. But we don't have stars in laboratories. We don't have clouds of gas big enough to weigh suns. What we do have are particles, tiny fundamental dancing points of energy that make up everything you know: your breath, the breeze, the black holes themselves. Could a particle accelerator, like the Large Hadron Collider, smash particles together with enough force to make a miniature black hole? The idea isn't new. In fact, some of the most imaginative physicists have asked this very thing. When particles collide at near light speed, the energy compressed into a tiny space is immense. Under the right conditions, some suggest, this could curve space-time just enough to form a fleeting, subatomic black hole. Not a city-sized monster, not a danger, but a black hole so small it would vanish almost instantly in a puff of Hawking radiation. A blink. A whisper. No such black holes have ever been detected in our accelerators, but the idea lingers, folded into the edge of what might be possible. And some physicists propose that if extra dimensions exist, hidden spaces beyond our usual three, then black holes could form more easily at small scales. A single extra fold in reality could lower the threshold, opening the door to black holes, not from stars, but from sparks. This brings us to the realm of theoretical physics, to string theory, to brains, to models that stretch the imagination like taffy. In these models, black holes are not just astronomical oddities, but tools to probe the nature of space and time, to test how gravity behaves at small scales, to reveal how quantum mechanics and relativity might one day speak the same language. In these imaginary labs, we build black holes out of equations. We model them on computers. We trace the paths of particles near their event horizons. We ask questions. Could a black hole act like a particle? Could it carry charge? Could it have quantum properties, spin, flavor, even entanglement? And from these questions emerge concepts like the black hole atom, where quantum black holes behave like the tiniest building blocks of matter, or the black hole laser, a speculative idea where a stream of particles bounces inside a curved spacetime, amplified by the strange mechanics of the horizon. Of course, none of this has been seen. These are dreams nestled inside the architecture of mathematics, beautiful, fragile, possible, but unproven. Still, the thought that we might one day create, or at least mimic, black holes in the lab is deeply human. We reach into the void not to control it, but to understand it. We build particle accelerators not to play God, but to listen more closely to the universe's hum, to recreate in miniature the conditions that existed at the dawn of time, to ask softly, what happens if, and perhaps, more than building black holes, we might build their analogs, systems that behave like black holes, even if they aren't made of mass. Scientists have created sonic black holes in supercooled fluids, places where sound waves cannot escape, just as light cannot escape a real black hole. Those are dumb holes, as they're affectionately called, because they trap sound instead of light. But the mathematics is startlingly similar. These systems let us test the behavior of horizons, of Hawking radiation, of how particles behave near a boundary from which escape is impossible. They are not black holes in the cosmic sense, but they are shadows of that same mystery, reflections in water. And if we can learn from reflections, we can learn from light as well. Some researchers have proposed creating optical black holes, manipulating the flow of light in such a way that certain regions trap it, forming a horizon of a different kind. Again, not in mass, but in behavior. These analogs are tools, prototypes, stepping stones toward the deeper truth, and in their quiet, fluid curves, we glimpse the structure of something ancient and vast, a shape the universe has drawn again and again, the spiral, the well, the point of no return. We may never build a true black hole in a lab. The energy required is immense. The risks, while probably small, are not zero. But the pursuit is not really about building. It's about becoming fluent in the grammar of the cosmos, about understanding gravity not just as a force, but as a language, a tone, a presence that can be studied, tested, even played with. And isn't that what science is, at its gentlest? A kind of lullaby for the curious, a way of humming questions into the dark and listening for the echoes. So lie back now. Let your thoughts spiral like particles in an accelerator, tracing invisible paths toward wonder. Somewhere, in the minds of physicists half dreaming at their desks, black holes are being born, not from stars, but from equations. not to swallow worlds, but to illuminate them. And perhaps one day, in a lab cooled to the edge of absolute zero, or in a collider circling quietly beneath a distant field, we'll catch a flicker, a micromerger, a black hole so small it lives for less than a breath. And even as it vanishes, we will listen, we will learn, because the universe is not stingy with its secrets. It shares them softly in whispers and waves, and we, ever curious, ever dreaming, are learning to hear them all. There's something about the edge of things that draws us, the rim of the ocean, the top of a hill, the moment before sleep. It's a space both between and beyond, not quite here, not yet there. And when it comes to black holes, that edge has a name, the event horizon, a boundary not of matter, but of meaning, a place where the rules shift, where forward becomes inward, and where the future curves into the dark. Tonight, as the quiet of the world wraps gently around you, let's go there, not in danger, but in thought, not with fear, but with wonder. Let's fall into a black hole. Let's imagine what that journey might feel like if feeling were still possible. Let's drift, step by slow step, toward the place where time and space are no longer strangers. We begin far away, at rest, floating in the soft vacuum of interstellar night. Before us, a black hole, small, dark, deceptively still. It looks like nothing. A void cut into the stars, not glowing, not pulsing, just there, waiting. Surrounding it is an accretion disk, perhaps, a halo of gas spiraling in, heated to brightness by friction and fall. But you are outside that, further back, in the silence, watching. As you approach, the first thing you notice is not the black hole itself, but what it does to the light. Stars behind it bend, curve, twist around its shape. You're not just looking at the hole, you're looking at a warped version of everything else. A gravitational lens, bending space-time so tightly that light orbits it like a trapped thought. You see stars repeated, smeared, a ring of fire where light skims the edge before diving in. And still, you drift closer. At some point, you begin to feel the pull, gentle at first, like the tide, then stronger still. Gravity increases not linearly, but with intimacy. The closer you come, the more you are drawn. And as you fall, you accelerate. There is no need to push, no rocket required. The black hole takes you. You pass the threshold where turning back becomes impossible. You don't feel it, not right away. The event horizon is not a wall. There's no flash, no bump. From your perspective, nothing changes. You're still floating, still falling. But to someone watching from afar, you have begun to vanish, slowing down, reddening, fading. You are stretched in time, your last image frozen just above the horizon, caught in a long goodbye. Inside, time bends around you. All directions now point inward. Space becomes time-like. There's only one destination, the singularity at the center, the core of curvature where physics as we know it cannot follow. And between here and there, a passage, strange, silent, absolute. If the black hole is small, tidal forces stretch you, not metaphorically, but literally. Gravity at your feet is stronger than at your head. You are pulled apart, spaghettified as the term goes. A soft, absurd word for something so final. But if the black hole is large, supermassive, the gradient is gentler. You might pass the horizon unharmed, floating intact through the threshold into darkness. And what is that darkness? It's not black like the night. It's deeper. It's the absence of direction. No stars, No return, just the inward curl of space-time, folding you toward the singularity. No escape route, no pause button. The laws of physics give way to unknowns, theories stretch, equations break. But maybe, just maybe, something else lies there. A wormhole, a bridge, a pocket of reality stitched to another. Some theories suggest that black holes could connect to other regions of space-time, that what falls in might re-emerge elsewhere, changed, blurred, but preserved. We don't know. We may never know. For now, the singularity is the end of our map, a place marked not with dragons, but with math that whispers, "Here I stop." And you, if you could think, if you could feel, would approach it not with terror, but with awe. The center is not a place, but a boundary of knowledge, a point so dense, thus so curved, that the path of time ends there, not abruptly, but inevitably. You don't crash into the singularity. You are drawn into it, folded into it, the same way a thought disappears when a dream ends, not violently, just completely. And what becomes of you, no one knows. Maybe you become part of the mass. Maybe you are reduced to information. Maybe your data is smeared across the horizon, encrypted into the surface of space, like a final stanza in a poem. Maybe you vanish entirely, or maybe you continue in some other place, some other geometry, where space and time write different rules. Outside, the universe continues. The black hole rotates, perhaps. It emits no light, but it spins. The shape of the horizon bulges. It pulls on nearby stars, curving their orbits. It grows if it consumes more matter. And far, far away, the waves of its birth, the merger that made it, ripple outward still, stretching space-time with a rhythm older than most galaxies. Someone on Earth might detect those waves, measure them, mark the coordinates. They might know that something profound happened long ago in a place too distant to ever visit. But they will never know what it felt like inside. That part is lost, or kept, or translated into something we haven't yet learned how to read. And maybe that's enough. To know that there are places where physics still hesitates, where questions outweigh answers, where falling becomes forever. To know that black holes are not holes at all, but bridges to understanding, symbols of what we do not yet grasp, wrapped in the language of mass and light. And to know that even falling, even surrender, is part of the story. That to fall into a black hole is not just to end, but to become part of something larger, deeper, curved. So rest now, with that thought curling softly around your mind, the idea that even at the edge of the known, there is grace,